Okay, exercise 3.6 deals with solving quadratic equations with complex roots. Now, we're used to solving equations like this. Sorry. So we're used to solving something like x squared, a times x squared plus b times x plus c equals 0, and we use the minus b formula. Now for complex numbers we're tending to use the variable z instead of x. So if you had an equation a times z squared plus b times z plus c equals 0, you can solve it by using the minus b formula from your table book. Here's an example. Example 1, you have z squared minus z squared minus 4z plus 13 equals 0. So first we'd state our formula. Z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Then we're going to say a from the sum, if you like, is equal to 1 as the coefficient of z squared. B is equal to minus 4 as the coefficient of z. And c is the number, which is plus 13. And we sub in, and we get, if b is minus 4, then minus b is plus 4, plus or minus square root of minus 4 to be squared, that's b squared, minus 4, a is a 1, and c is a 13. And that's all over 2 times 1. And that's equal to 4 plus or minus square root of minus 4 to be squared is plus 16. Be careful now, it's not minus 16, it's plus 16. You got minus 4 times 13 is minus 52 over 2. If we tidy up then again inside the square root sign, you have 16, take away 52, and that's a minus 36 over 2. You've got a 4 plus or minus. Now we're going to change the minus 36 to the square root of 36 times the square root of minus 1. So minus 1 times 36 is your minus 36. That's over 2. So you have 4 plus or minus. Square root of 36 is 6. Square root of minus 1 is I, and then over 2. And just again, you can simplify further. 4 divided by 2 is 2. Plus or minus 6 divided by 2 is 3i, and that's your answer there. Now, this is really important. When we have complex roots, just like we had in that last example, they're normally occurring in pairs. So you'll normally have plus or minus 3i, like 2 plus 3i, 2 minus 3i. We call these conjugate pairs. Now this only happens when the coefficients of the original are real. So in other words, you see here the coefficient of this one is 1, minus 4 and 13. They're all real numbers. So that means we're going to get conjugate pairs, as we did in this case, as an answer. So this leads us to the general conjugate root theorem, which says that if the coefficients of a polynomial are real, then all complex roots occur as conjugate pairs, just like in the example above. Okay, let's look at the next example. You have, if 1 plus 5i is a root of this equation here, find the values of a, b, and c. Now a, b, and c all have to be real. Okay, so in order for it to follow the conjugate root theorem. Okay, so what we start out doing is if 1 plus 5i is a root, then the conjugate root theorem tells me that 1 minus 5i is also a root. And that's according to the conjugate root theorem. Again, that's only when all of the coefficients of the equation are real, as they are in our example. Okay, so now we have two roots, 1 plus 5i, 1 minus 5i. Now what we say is that the equation that has these two roots will be of this format. It will be of z squared minus the sum of the roots times z plus the product of the roots equals 0. So we just sub in. Sum of the roots means we add the roots together. So the first root is 1 plus 5i. And we add the second root, 1 minus 5i. That's to be multiplied by z. Plus the product of the roots are 1 plus 5i times 1 minus 5i. That has to be equal to 0. Z squared minus 1 and 1 is 2, and these are cancelling 2z. Now we need to multiply out these two together. Now I'm going to take a shortcut. You can split brackets and do it the long way if you want, but the shortcut is, this is like x plus y, x minus y, and the answer will be x squared minus y squared. So this thing to be squared will be the answer. 1 squared minus this thing to be squared will be the second thing. So if you square the 5, you get a 25, and you square the I, you get an I squared equals 0. Z squared minus 2z plus, okay, 1 squared is 1, I squared is minus 1, times minus 25 is a plus 25, and you end up with z squared minus 2z plus 26 equals 0. Now to present your answer, we want to see what a, b, and c are. A being the coefficient of z squared, b is coefficient of z, and c is the number. So a will be equal to a 1, b will be equal to a minus 2, and c will be 26. And that's your answer there.